This episode is sponsored by SwageLock.
Managing hydrogen safely and cost-effectively while meeting performance benchmarks and reducing downtime is critical to building a sustainable clean energy future. That's why industry leaders trust SwageLock. With SwageLock, your team is a lot bigger. You have access to hundreds of fluid systems experts around the world who can keep you and your systems online and operating efficiently. Learn more at swagelock.com/alongside you.
Hello and welcome to the 1895 podcast with me, Thomas D.
And me, Rob Cockerell.
Rob, how you doing? We're into December now, in the business end of the year, I suppose we can call it.
We are the business end of the year. Decidedly cold here, I have to say.
Yes.
I know we've talked about temperature quite a lot recently, but I could do with some hot topics to warm me up here.
Well, especially when we're coming back from places such as Austin, coming back from Bangkok.
Yeah.
Two warm places, back to the UK, back to the... Feels like -5, I think we saw today.
It does, but as you said, it is nearly the end of the year, and I guess we are here to talk gases and hydrogen.
Yes, and like you say, diving into those hot topics, and we in fact have a guest on this podcast, a guest that's familiar with the 1895 audience, and we're once again joined by Chuck Hayes of SwageLock. Great to have Chuck back on, isn't it? Rob?
Absolutely, yeah. So Chuck, what's new with you? What's new with SwageLock?
Things are going well. We're still playing in the hydrogen world. Hydrogen seems to be slowing down a little bit in the United States due to current administration, but still a very hot topic in different places around the world. Europe's a little slow, waiting for some decisions to be made in Brussels, but Asia is going very, very hot right now. A lot of work going on in India and Malaysia, Indonesia, Thailand, and of course China and Korea. So lots of work in different places around the world.
Sure, yeah, and as we've said, we're right near the end of the year now. So how has 2025 shaped up for SwageLock? Has it been a busy year for you guys?
Organizationally, for all of our industries, yeah, it's been very busy. Very, very busy year all over the world. Clean energy and hydrogen's down a little bit this year. We kind of expected it going in, but we're seeing some rebounding potentially coming in the future.
Sure, and this is a sentiment we've been seeing right across the hydrogen industry in particular, isn't it, Rob?
It is, yeah. That just makes me ask, Chuck, actually. I mean, you're global technical lead at SwageLock. You're a 30-year veteran of the company. You spent the past 20 years focused exclusively on fitting technology for alternative fuels. I'm pretty sure I've asked you this before in a previous conversation. Is this the most exciting time you've seen in hydrogen or energy or decarbonisation, however you want to term that? Do you still feel that's the case? And given some of that market turbulence, is it still a great time to be doing this?
It truly is. I think the big difference right now is that excitement is turning into actual projects. So where everyone was really excited and wanted to jump in and everyone wanted to get involved, now what's happening is the real players, the real people that are really going to make the difference are the ones that are still here and still working. And those are the projects that are going to take us forward into the world. The big projects, the big problems right now, I think the president of Hydrogen Europe said that the problem in Europe right now is there's not enough ways to transport hydrogen in Europe. So while there's enough being generated, it's getting it to the places it's needed. In the United States, there's not enough hydrogen being made, but then at the same point, there's not enough off-takes. There's not enough people committing to taking hydrogen once it is made. So therefore, people aren't making it. So there's a lot of chicken and egg issues going on still globally. People that are solving that are people, like I mentioned before, Indonesia, Malaysia, India. They're going holistically, and the governments are getting very heavily involved in making sure the entire start to finish ecosystems are being created simultaneously. But now there's a lot of movement for shipping. There's a lot of movement for a variety of other things to take over and become really, really important for making ammonia and making some other fuels out of it for shipping industries and so forth. So we're seeing a lot of movement in that area, and a lot of very large hydrogen programs going into play.
And I guess a lot of learnings that some regions can take from others, like you say, the US and Europe, for example.
Sure. And, there's been a lot of movement towards carbon capture, and some, honestly, there's some programs that don't seem to make as much sense. Putting big fans on top of mountains to capture carbon in the air, it just doesn't seem like the most efficient way to do it. I'd rather capture it at the point that it's being created. So there's been a lot of money spent on things like that. They seem like neat scientific projects, but not the most practical things in the end. We're finding that hydrogen in light-duty vehicles may not be the answer, but heavy-duty definitely is in vehicles. And there's lots and lots of talk around data centers and backup power for hydrogen to replace diesel and natural gas in those areas. And that's a great way to do it and a great place to put it. So really, where it's going to be used and how it's going to be used, it's not for everything. And I think in the past, where all the excitement was, let's use it for absolutely everything. And nowadays, I think people are saying, let's use it where it's practical and where it makes sense. And that's where we're going to be seeing it as we move forward in the decarbonization.
And that is what we've been hearing with all the conversations we've been having on this podcast, in our magazines, on our webinars, that there really is no silver bullet to this energy transition. And it is horses for courses, to coin a saying here in the UK.
It is, absolutely. And as we've just discussed, it's very much a different regional plays, different, push-pull factors. But I guess all of that, Chuck, means, that brings us neatly to our topic today, doesn't it? Around really we need to navigate standards in hydrogen and the complex world of standards and the certifications that are going to shape the hydrogen industry.
Yeah, it certainly does. And, while there is no single global standard for clean energy transportation, there are still several standards that do maintain significant influence on our various industries. So Chuck, what are some of the most prominent or maybe established ones that our listeners should be aware of?
Well, there's two major categories. So there's on vehicle, and then there's infrastructure around that. So we'll start with on vehicle. So on vehicle is really guided by one overarching set of requirements, and those are put out by the United Nations. The United Nations has a set of requirements that are called GTR 13, global technical requirements, and GTR 13 governs the safe use of hydrogen on vehicles. That flows down, and that's been signed down by all the United Nations countries. That flows down into other regulations. In Europe, that flowed down into two sets of regulations for the EU. It was EC 79, and then the documents below that, which was EU 505, that told you how to meet the EC 79, and then ECR 134. What happened, unfortunately, a few years ago is they sunsetted EC 79s. EC 79 actually had regulations in it for how to test and approve individual components on a vehicle. That document was sunsetted and without anything to replace it. So it's made what was a very straightforward way to approve components very convoluted now. R134 was thought to be the replacement, but it truly isn't. It covers three sections. It covers the tanks themselves on the vehicle. It covers the tanks plus the tank valve, a check valve, and the thermal pressure relief device together as a subsystem. And then it covers the whole vehicle as a whole in three different segments. So things like rollover testing, crash testing, and then other parts of the system, including like the dash lights, the air lights and things like that. But it doesn't really cover components. So, in fact, fittings are only mentioned in it 4 times in the whole document. So how do you build a vehicle knowing that your fitting choice was correct? That makes it difficult for a truck manufacturer, let's say, and that you have something that's going to work. You don't want to wait until you're doing crash testing to make sure it's going to be okay. So now ISO has put out a document. It's 19887-1 for individual components that basically mirrors what EC 79 did. And parts can be tested and approved to that. And we have many of our products are already done. We have a few last parts that are going out for test literally right now. They're in test, and they'll be done shortly. So that's one way to do it, is you do all the individual tests. And then what happens is the vehicle manufacturers roll all those different parts together and go through a series of testing and approvals in the EU theater that goes up to what's called FAZIT, F-A-Z-I-T, and that's where your approval bodies will take all of the different components on the vehicle, all the different tests that were done, and compare those to other tests that need to be done to approve a vehicle for roadworthiness. So a vehicle needs to be approved for roadworthiness to go out on the road. So that's how vehicles work. And that's very similar to any vehicle that's on the road today for gasoline or natural gas. They all have to be approved and go through all the different testing and all the protocols to make sure they're safe for us to be on the road. There's another set of standards that are out there for making sure stations are safe, and infrastructure and electrolyzers and fuel cells, and those tests and those standards come down either from EU or from people like ISO. So ISO writes a variety of standards. ISO standards are global and adopted by a variety of countries, or there are local or regional standards as well. So here in North America, we also have CSA. The Canadian Standards Association is partnered with ANSI, American Standards Association, but CSA writes the standards and publishes primary for U.S. and Canada for both vehicles and for infrastructure, and we work for all the standards that are here. And, like you said, there's no one standard, but we work very closely with ISO to try to harmonize. So we want to make sure we get closer and closer to having one standard. So oftentimes we will adopt an ISO standard once it comes out into the North American standard, so that we have a single set of requirements. We call that harmonization. We work very hard to make sure we harmonize as much as possible. And then countries like, for instance, India has adopted a set of the ISO standards into their national standards. So as standard writers, and I'm part of, in CSA, I'm the vice chair for the technical committee that writes all the hydrogen standards. And I sit on the ISO plenary groups, which are the leadership committees for that. And we work very hard to try to make sure we're harmonizing as much as possible. So we have the same requirements around the world. And again, everything rolls back up to that GTR 13, ultimately, in the end. But we want to make sure everything's as close as possible. Things got a little bit difficult when you guys a few years ago broke off with Brexit, when that took place, because you broke away from the European Union requirements. So now there's some new British requirements that are based on what the European Union was originally. But it became difficult on certain things like transport of tank trucks. Tanker trucks require a slightly different requirement, which is called TPED, Transportation Pressure Equipment Directive, and special marking for any valves and systems that are there in Europe. There's now a separate marking in Great Britain, but obviously to do transport of goods, they come across the channel and they transport goods back and forth. So those things have to be harmonized in such a way that we can continue to have commerce moving back and forth and moving product, between Great Britain and the Central Europe. So a lot of these things get kind of complicated. And the whole idea is, let's not shut down any of the commerce. Let's not shut down, moving forward. We've had standards out for hydrogen. We started writing them in the early 2000s. We make revisions now as necessary based on either incidents or learnings as we move along. We're starting to write new standards for aircraft, for drones, for trains, and that work's going on at ISO and at CSA. There's some maritime work being done by some of the larger bodies, including Lloyd's and DNV, to make sure those rules are put in place. And we're trying to make sure we're harmonizing on those types of things as well. So lots of work being done on the standard side to help, first and foremost, keep people safe and not make it so onerous that we can't make product to make it work. So, and then it's up to companies like us to make product that it meets these standards and meets the testing for them, so that we do make it safe for people to be able to use product in the industry.
Sure. Well, it is a real complex world of standards and navigating those various standards, isn't it?
Oh, I saw one graph one time that had like the center of products in the middle and then a bubble chart all the way around it, and there was just hundreds and hundreds of different agencies and people and standards all around for different things in this area, and it is kind of crazy sometimes how big it gets.
Yeah, I mean, it's an absolute universe, clearly, isn't it? I was just thinking about the layers of depth to all of this. If I try to, it seems ridiculous to do so, in fact, Chuck, but if I try to simplify things a bit and just, I mean, from a layman's point of view, I mean, what does it mean when a product is listed for certification? So
a couple of different things. When we go ahead and take something out to get listed or certified, it means that we've gone through a third-party test lab. and the parts have been tested, and then it's gone to an authorized body. So oftentimes we test our products through Kiwa, which is a test lab in the Netherlands, and their authorized body is RDW, which is the national body in the Netherlands, and they'll go ahead and put an approval on it. There's a variety of different bodies. There's 3 or 4 different TÜVs out there. TÜVs out of Germany, BSI is one in Great Britain. CSA can do it in the United States. We also use the Irish body at times for different things. That authorized body is just it's a government body that puts their authorization on it and puts a stamp on every page. And they're the ones that have said, okay, we've accepted this test lab's testing. You've done it to the standard, and you've been approved. Is it necessary to do it at all times? Not necessarily. Sometimes the third-party test lab reports is enough. Depends on who the company is and who the authorized body that's going through the final approval is at the end, of whether they need the full listing or whether they just need the test reports from the lab. But in most cases, or almost all cases, doing testing just ourselves in our own labs, which of course we do prior to sending it out, is not enough. It's not enough to just do your own testing and have your own test reports. An independent third-party lab is required. And there's not a ton of labs in the world that do these tests. These tests are oftentimes at high pressure, and when we're talking high pressure, we're talking 1,000 bar or 15,000 psi. In gas, in hydrogen, they need to have bunkers set up to keep people safe in case anything lets loose. That's a lot of energy letting loose a gas at those type of pressures. There's special safety precautions or special equipment that does this. This just isn't any lab that can do it. So there's only a limited number in the world that can do these types of tests. And working with one that is good and effective is important. That communicates well and so forth. There were a lot more people that did testing for natural gas in the old world of earlier testing for certification.
Great, thank you for that, Chuck. And just to move on now to fluid system components, a topic we've covered with you and plenty of your colleagues throughout this year as well. This is testing is performed to a wide range of different performance criteria here, including corrosion testing, burst testing, hydraulic testing. We've got vibration testing, pressure testing, so many more testing, as well. Yeah. So many different types of testing. So perhaps you could just tell us what the different types of documentation that are available are for these various types.
Yeah, so when you're done, when you go through the test, and the tests are all defined in the standards. So if you just take the ISO 19887, it's a fairly long document. It's probably close to 100 pages long, and it explains for each type of component what the tests are that are required. It'll explain what media you have to use. So let's just say you're doing a cycle test, how many cycles, ranging from what pressure to what pressure those tests are done, at what temperatures that they're done at. And then when you're done, you'll have you do that test, and then you're going to do a series of hot and cold leak tests. You're going to do a variety of other tests that go into the whole process. Probably 10 to 12 major tests that go into it, ending usually with a burst test. If it's a valve, you're going to do an open and close testing. You're going to do corrosion testing usually to start, and then do all the rest of the testing afterwards. Most of these tests are done in sequence, so it really is kind of bad if you fail like the last high temperature leak test, because you've done all the other testing already. But in the end, you get a test report from the lab that basically explains how they tested it, what all the conditions were. Think back to a high school lab report, all the conditions, what gauges were used, how it was done, how many tests were done, that you passed each one of those tests. And that's the test report. So that's important for the engineers at the end to see that how you passed everything. Along with that comes a declaration. And the declaration is a different piece of paper, which is the letter that says, we as this test lab state that you have passed based off of this set of requirements. So you passed this to ISO 1987-1 and the year for these components. That, if you're getting listed, will be stamped and certified by the notified body. and that'll show that you're listed at that point. You also have you can have a few other things. You can have something called a letter of attestation. That's just a one or two pager that basically says the same thing, but it's not as formal. So that's what you have: your declaration, your test report, your letter of attestation, and those basically are the different things you can have. They're kind of used at different points in the project. If you're starting to work with a customer and they say, we need to have these tested in accordance to this test, do you have proof? A declaration is enough, or a letter of attestation is enough just to get them started. At the end, by the end of the project, they're going to need the full test reports and everything else. So just to get started, the declarations are fine. Typically, manufacturers will put the declarations on their website, but not the full test reports. We'll do that at a later point in time. There's nothing secret in the test reports. They basically say you met the requirements that were in this other document, and you passed them all. But that's kind of the documentation that you get, and it has to be made available from us to the customers upon request.
Great, thanks for that, Chuck. And just to continue that, you talk about documentation there. What is the real importance of that documentation?
I'm glad you asked that one, Tom, because I don't want to be asking all the the stupid questions.
It's your proof. It's our proof point. We publish lots and lots of different test reports. We have test reports publicly available. They're called product test reports. They're available through our electronic means, electronic catalogs that talk about things like burst and gas seal remake testing and all kinds of different things, are hot and cold performance and cycle life and so forth. But these state that you have met the requirements of this particular standard. And that's what's important to the customers. That means you've met this certain criteria that's been designed by the industry, and you're able to be put on vehicles to perform safely as defined by the standards. That's important. That gets you to the next stage, and it's there to be able to help protect the public. That's what they're there for. That's what the tests are there for. That's what the standards are there for. If at some point we've determined that we didn't have enough things in those tests, we will add new tests to it and make those requirements and update those requirements to add additional things to protect the public. That's the whole point.
It's quite obvious when you spell it out like that.
Well, it is, but I mean, what I wanted to add there, I mean, I guess that's all important to that umbrella of perception, of public perception, of transparency and regulatory confidence.
Yeah, right. And it's important that and it's important when you're developing something like a vehicle that I can't imagine. I've never seen an actual submission for a vehicle, but I can only guess just the stacks of binders of paper that go along with it for every single component of every test report, all stacked up to say all of these together are safe to make the vehicle be safe in the end. And that's, we're just talking about the fuel system here for the gas. I mean, there's everything else on that vehicle has to be safe too. It is truly amazing that you've got this thousands of pounds going at very high speeds on the road all day long, and these things are not falling apart and not, and they're keeping people safe and keeping families safe all the time. So hats off to the folks that build these vehicles and keep us safe and keep our families safe all the time. And now, we've changed the fuel. We don't think about it, but gasoline itself is flammable and explosive, as is propane, as is natural gas, which fuels we've used for years as well, as is, hydrogen. They've all got their flammability issues and so forth. But we've done it safely for years, and we'll continue to do it safely. And that's what the standards are all about and what they're for. And it's all about keeping people safe. And, our job is to make high quality components that meet those standards or in most cases dramatically exceed those standards. And then we help write those standards. And we're part of that to make sure, and that's another piece of my job, to be a part of all of that process and making sure that we're continuing that legacy on into the future.
Absolutely. Couldn't agree more.
Yeah, and it really reminds me of a quote that we had on a webinar maybe earlier this year or last year, that if gasoline cars were being introduced today, they probably wouldn't be approved.
No, absolutely.
Yeah, probably not.
But we are running out of time on this podcast. Chuck, and indeed running out of time this year. But hopefully we will be able to continue the conversation with Swagelok next year. What's 2026 shaping up like for you? Is it going to be a busy year ahead for you guys?
It's always busy. We're there helping customers, moving in, new people doing new things, helping those customers win, taking our experience, and helping people not make mistakes that other people have made in the past, and moving forward. And the landscape's going to keep changing. Some things are going to go fast, some things are going to go slow, and we'll see as that moves. And we'll be there to help. And that's what the whole thing is. And handle it safely and bring forth the future for whatever it's going to end up looking like.
And do you expect those same regions and even specific countries that you talked about earlier to be the same kind of dominant drivers next year?
Absolutely. Yeah, those regions are going to be big. I think one of the big ones is right now, like EU, one of the problems with the EU is you've got the 2035 boundary for vehicles. So, and I think Great Britain has 2032. Right now, the laws are that there's no internal combustion engines after those dates to be sold. And then they have to be totally phased off the road. I can't remember what the date is phased off the road. I think it's 2045. But that means that there's some things that are difficult for people to understand. And right now, internal combustion engines for hydrogen would not be allowed, and fuel cells are not going to be allowed as a part of the clean energy. And they're trying. That's what I said earlier about Brussels making decisions. It doesn't make sense that fuel cells wouldn't be allowed in that entire world. So, are we going to build stations for hydrogen if they can only be there for another 10 years? Does that make sense? Is the investment there from a business standpoint? So they're trying to get that rule changed to allow for fuel cell vehicles into the distant future, and that will make a major difference, reaccelerating the market in mainland Europe. And I think if those rules change in Great Britain, it's the same thing. But it's hard to make heavy investments, and those are steep investments to make without knowing where it's going to be in the future.
Absolutely. None of us have got a crystal ball on that, have we?
No, we certainly don't. But I do instantly see some talking points that we can pick up on next year. Chuck, thanks for your time today. And thanks to you and your team's time throughout the year. Some great conversations with Swagelock throughout 2025.
Fantastic. Yeah, absolutely fantastic depth.
And to get that wealth of knowledge and expertise on this rather complex topic sometimes is invaluable. So thank you once again, Chuck. To our listeners, we'll be back again next time with a fresh episode of the 1895 podcast. But in the meantime, do please like, follow and share. This episode is sponsored by Swagelock.
Managing hydrogen safely and cost-effectively while meeting performance benchmarks and reducing downtime is critical to building a sustainable clean energy future. That's why industry leaders trust Swagelock. With Swagelock, your team is a lot bigger. You have access to hundreds of fluid systems experts around the world who can keep you and your systems online and operating efficiently. Learn more at swagelock.com/alongside you.